Hi, my name is Robert Anderson. I'm Vice President of Integrated Products for Nemetschek North America, makers of Vectorworks. Today we're going to talk about BIM in the real world. BIM is one of these acronyms that has come around and is very popular in the architectural technology world today. And today we're going to talk about a variety of things. We think of BIM as a philosophy more than as a pure technology. In many ways, Vectorworks has been doing BIM for over 10 years. Today we're going to talk about visions of computers and architecture, a new way of looking at buildings, what BIM is and isn't. And right about now you're probably thinking, oh my gosh, this guy's going to just read his slides to me. Well, I'm not going to do that really. I was just kind of playing with you. Today we're going to tell a story, and I'm going to show you some slides, and hopefully the sound of my voice and the showing of the slides will come together and make a good whole for you. So let's get started, but let's start by taking a look ahead by looking backwards. Bruce Goff, iconoclastic architect, visionary, one of my heroes for sure. He had an interview in 1983 with Robert Morris, a classmate of mine at Rice University, and he was talking about the impact of technology on architecture. And he had some interesting things to say in '82. This, remember, was about the time when AutoCAD was really just getting started. In fact, it was really very little known at that time. And he was comparing the creative endeavors of architecture with the creative endeavors of the music profession. And he'd seen what was happening with synthesizers in the music profession. And interestingly enough, he came to the conclusion that architects, like musicians, were going to be able to leverage their creative efforts, and really that a lot smaller creative effort was going to be able to be spread out over a lot larger project. And I like what he says there at the end. He says, eventually the architect will be able to conceive and execute a building almost entirely himself. Of course, he must first have some ideas. And it was those ideas that was really what Bruce Goff was all about. His work, if you're familiar with it, is very original. And he was always fascinated with new ideas and bringing those new ideas to the public. Clearly, good ideas, new ideas were what Bruce Goff was all about. And also, what he saw as the architect's contribution to society. Now let's look at a vision that may not quite be so benign. Kurt Vonnegut, another hero of mine really, and he knew something about architecture. Both his father and his grandfather were architects. In fact, his grandfather was the first registered architect in the state of Indiana. And his father was a successful architect up until the time he came into the beginning of his mid professional life when the Great Depression hit. So he was guilty, if you can think of it this way, of having bad timing, and it was something that Kurt never quite forgave his father for. In addition to knowing something about architecture, Kurt Vonnegut knew something about suicide. His mother committed suicide when he was home on leave from World War II in 1944, after he'd seen the firebombing of Dresden, which became the basis for his seminal book, Slaughterhouse-Five. His vision is a little different. He sees the contribution of the architect as mostly doing drawings and not necessarily those good ideas. And in fact, in his vision, there are no ideas, and the drawings are functions of menus after menus, and the software really kind of replaces the architect. It's a very different kind of vision, one where the computer replaces the individual. And in fact, this is a theme that Vonnegut visits and revisits many times over the course of his literary career. So these two visionaries have given us different ways of looking at the relationship between architecture and technology. And how do we think about our buildings? And technology will ask us to think about our buildings perhaps in different ways. I used to work for a quite good architect named Bill Kennedy, and Bill has a practice in Houston, Texas, and he'd come around on Monday mornings and ask his young production staff, well, what do you think good quality beefsteak cost per pound? And we could usually come up with the answer for that. And then he'd ask, well, what's that BMW out in the parking lot cost per pound? You know, those of us who could work the back of the envelope would come up with an answer for that as well. And then he'd point to your drawing board and say, well, what's that building you're drawing on cost per pound? And we'd scratch our heads and not really have any idea. So what this BIM, this information modeling, is going to help us do is think about our buildings in different ways. But it's certainly not going to relieve us of the requirement to be able to know how buildings go together. So BIM is going to make us look at buildings just the way Bill made us, young architecture pups, look at our buildings in a different way. And so I want to start by asking, and for those of you who've been involved with PIN registry drafting, you know the first rule, which is draw it once, and that quickly became the first rule of CAD with simple layered 2D CAD as well. So one way of thinking about BIM is just to say it's a re-expression of this old approach, where you're using document structuring to leverage your multiple views, the same geometry, but you're moving it into 3 dimensions. And that's a valid way to look at it. But BIM could also be looked at as methods, technical and technological methods borrowed from other industries. These concepts and these techniques mostly come from the vehicle manufacturing industries, automotive and aerospace, multiple simultaneous views, interference checking, the idea of change management where changes in one view affect all the other views, etc. These are methods that are borrowed from the automotive and aerospace industry. So let's take a look at automotive and aerospace and see how they compare contextually to building design. If you look at an automotive or aerospace project, you'll see there's really a relatively small number of highly precise machined, manufactured pieces that are described individually and then assembled in these things called assembly drawings, intended for mass production, where the artifact that you're making is mobile. In other words, the point of manufacture is not the same as the point of use geographically. Let's compare this to a building. In a building project, you have large numbers of very imprecise pieces, most of which are site fabricated, described in place, in situ. And by that I mean, if you look at that stair section, for example, you'll see that all the pieces are describing an intended result. And this is why we say that our construction documents are conceptual in nature, because they describe the intended result of what we're trying to achieve, not the process by which we're going to get there. Architects, in current legal terms, describe the result, and contractors are responsible for the means and the methods of production. Obviously, they're intended to be unique, and they're constructed in a single location, so the artifact is not mobile. It's the point of use and the point of creation are the same. So how could a building be more different from an automotive or aerospace project? If the entire cultural context is different, it makes sense a little bit that the process could be different. So why are we adapting these processes to our work? And I'm not saying it's wrong, but I want to raise the question and get you to think about the process a little bit as well. And I will say that Frank Gehry deserves an aside. In effect, he's got buildings that are built like airplanes with these beautiful, smooth, and curvilinear skins, very precise. And so he builds buildings that look like airplanes, and so he uses airplane software, which is CATIA, to handle the production and, in fact, the manufacture of his skins and the frameworks that support his skins and the HVAC that sits inside that framework. It's a beautiful process so far as it goes, but it's not exactly mainstream. And I think it's worth asking the question, can buildings be manufactured? What if we change the process a little bit? This book, Refabricating Architecture, was given to me as a homework assignment by my boss the end of last year. And it's written by Stephen Karen and Jim Timberlake, both FAIA. Really an interesting book wherein they propose to use these automotive and aerospace techniques for buildings. And building and delivering buildings to the site in much bigger pieces with fewer but much more complex joints. Getting all the trades under one roof and controlling quality and centralizing the actual location of the manufacture. But I don't think it's realistic. Personally, I think their position is weakened somewhat by the pieces of architecture and construction that they choose to ignore, particularly that of our today's modern home builders, who have really taken some extraordinary methods in driving costs out of the construction process. They don't really take into account the cost of uniqueness and the capital costs of building the actual factories to build the buildings. So I think that they choose to ignore home building because they have sort of a modernist bias, and ultimately the book is a little bit of a polemic. But it's an interesting book, and it's worth reading, and I can highly recommend it. Okay, if there's nothing else you take with you from this talk, I'd like you to at least bear one thing in mind. And that is, when we talk about BIM, we're using one expression to mean two different concepts. And I've seen this has created, I think, a lot of confusion. And some of my competitors in marketing their technology products have used this confusion, I think, to sow some FUD, fear, uncertainty, and doubt. And I have heard people say things like, well, you know, here's this BIM and the train's leaving the station, and if you don't change, you're going to be out of business in 5 years, and it's intended to essentially sell software. And I have a problem with that because on one hand, what BIM represents is kind of a better CAD, a modeling and drawing technology that we at Nemetschek refer to as design BIM, or we think of it as essentially this better CAD technology that you can buy and put on your desk and use today. And so one aspect of BIM is very much of today and is available, and you can go out and do it and experiment with it and play with it and incorporate it in your projects as much as you want, and that's great. But a second aspect is of BIM is really an upcoming change in information technology and sharing for the entire construction industry. Instead of calling this BIM, I prefer to call this interoperability, as it is sometimes called, but not always. And people kind of tend to use the word BIM or the expression BIM to mean interoperability as well. In fact, if you look at the problem a little bit, you'll see that interoperability is really the economic driver that drives the need for BIM. So here's any speaker about BIM is going to show you this particular cover. This was an NIST Department of Commerce study in 2004 that said that by better information sharing in the construction industry, we can save $16 billion a year. Not chump change, but essentially this better information sharing, this interoperability, requires in turn object descriptions, object-based building descriptions to work. So in effect, interoperability is the driver driving this BIM, this better CAD. Before we leave this particular topic, let's talk a little bit about the winners and the losers and the gains and the losses. The study says that architects and engineers out of the $16 billion are only going to gain about $1.1 billion, and general contractors are going to gain about surprisingly small, frankly, $1.8 billion. Subcontractors are going to gain $2.2 billion, and they're going up a little bit, and that's not too surprising since they're the ones who have to do the assembly drawings, the steel shop drawings of our business, and they could benefit from directly accessing that model. But the owners, the people who have to manage the properties that we create with our architecture, are going to see a huge gain over the lifetime of the building commission of over $10 billion, $10.65 billion. And so, if the owners are gaining, is there anybody who's really losing? And I think that one of the issues, one of the sort of business model issues that we're going to have to properly respond to in this whole context is saying, architects are being challenged to put more information into their building model, to in fact virtually construct their buildings as opposed to just draw them at the front end of the design process. How, if at all, will they be compensated for this greater effort and potentially greater liability at the front end of the project? This imbalance of risk and reward, something I'll talk about several times today, is an issue that we're going to have to resolve. It's a business model that we have to resolve to be able to make this entire BIM interoperability thing make sense. So before we go very much further, let's talk about a working definition of design BIM. This is that better CAD, that technology that sits on your desktop. So what is it? Well, projects are developed with a 2D and 3D model, an integrated, unified 2D and 3D model. And I say 2D and 3D because you can model in 2D every bit as much as you can model in 3D. In fact, you have to have 2D and 3D held together or integrated. Think of the way you draw a wall outlet, for example, a duplex outlet in the wall. In Plan, you just draw it as a circle with 2 slashes, but in 3D, it's just a little sort of nondescript 2" by 2" by 4" box that sits recessed into the wall. And if you use the strict 3D drawing to represent that in all views, it would be very difficult to interpret a lot of what you need to communicate. So 2D as well as 3D are important, and this is a topic we'll come back to also. But so the first aspect is this 2D, 3D model. The second aspect is that all the parts of your building are described with objects. So now objects are going to be drawn as property-bearing objects, not just geometry. Third aspect is that the various views of this model are going to produce your drawing. So when you make changes to the model, and they're automatically reflected in all views, giving you automatic drawing coordination. That's a nice thing. And the last aspect is that the components, these model objects, possess graphical as well as non-graphical or non-3D properties. They obviously know something about their quantities, their costs. They might possess information about thermal or acoustic properties or other scheduling information. Some people call this the I of BIM, which is to say the information component. But these non-graphical properties are extremely important. But, and there's always a but, but BIM really doesn't know how buildings go together. This better CAD is certainly better, but it's still representational in nature. It can't draw what you don't explicitly model or specify, and it can't anticipate detail conditions. Now, it is computable. By that I mean, a door knows it's a door, and it knows it says to you, I'm a door, and you can draw me in these various configurations, and I can retain all the information that I need to have to be a door. But it doesn't really still draw what you don't explicitly specify. It's fundamentally representational in nature, and it can anticipate detail conditions. So you still have to know about that left-hand corner on the inside part of your courtyard and actually go back and figure out exactly how it's going to get detailed in space. It has some advantages. Some things are easier to model than to draw. A spiral staircase is the classical example. In 3D, it's actually not too complicated. It's a block, and you just basically step it and rotate it a little bit, and voila, you have a spiral staircase. But if you've ever tried to elevate one in 2D, you know that it can be kind of a bear. So it's nice to have this thing that you can model easily and have the system draw for you. And BIM, because of its model-centric nature, does a very good job of coordinating drawings, from the overview, from the general to the specific, the overview to the details, as well as between plan views and vertical views, elevations and interior elevations, etc. In addition, the automatic scheduling is really a boon. It's a natural fit for BIM and all this non-graphical data that it's managing in its database for you. But there are also some challenges. Just as some things are easier to model than to draw, some things are easier to draw than they are to model. I'd hate to have to model, for example, this beautiful oval Victorian block vent just to be able to incorporate it in my project. I'd like to be able to maybe just draw a little oval on one of my elevations saying block vent here. So drawing and graphics will still be important to the BIM workflow, and BIM software that requires a separate application can be costly because it can require you to learn and buy, and maybe even buy a second program. ArchiCAD requires you to learn also PlotMaker. Revit is still recommending that you incorporate AutoCAD for your graphical needs. It's also worth noting that some BIM software can be very compute intensive, a hog as we say. Sometimes parametric constraints and ubiquitous solids can be relatively sluggish, and it's hard for the software to keep up with the flow of ideas as the designer is drawing and manipulating his model. So evaluate your BIM software on this aspect as well, because they will chew up all the computing power you throw at it and more. I'd like to talk for a minute about BIM and the office culture, and a little bit about the culture of technology in architects' offices in general. If we look at what's happened and where we are today, we can say that CAD has created a two-tier culture at some firms. I call this the virtuoso problem. If you've ever seen a really good AutoCAD jock, for example, and I know many of your offices are based on AutoCAD, it seems to me like the really fast AutoCAD guys have learned the command line. So when you watch them, they're really quite something to watch. Their left hand is typing away at the keyboard. Their right hand is mousing, and the display is zooming in and out. It's really kind of an interesting eye-hand coordination issue, and quite a good example of eye-hand coordination. But the problem is that these AutoCAD jocks add so much value to the firms where they work as electronic pencil pushers that it's difficult to justify sending them out to the site, getting them to do some real construction observation, and getting them to understand how buildings go together. It's really, they've sort of created a glass ceiling for themselves because of the value they add as this electronic pencil pusher. But the problem, and that's a problem in and of itself relating to intern development, but BIM requires architectural and construction knowledge. So how will interns learn how buildings go together? And if I need, if I've got to have these people who really do, who are truly architects and fewer just drafters, will offices become topic? It's a real tough question, because the workflow process is going to change from the idea of one smart guy drawing up red lines, handing them out to 4 or 5 drafters. If everybody can get into this BIM model and make changes directly, that can be good and can be very productive. But people have to know what they're doing. The other aspect of this BIM technology is we need to know when to stop designing. We're going to see that our project service budgets from programming SD, DD, and CD are going to change, and we're going to be front-loading our projects more and moving things into the so-called low-risk area of BIM practice, and this is good. But I've seen people design themselves out of budgets. I've seen people design themselves out of construction budgets. I've seen people design themselves out of design budgets, and BIM isn't going to impose that discipline. There's a certain discipline with just having to produce a number of sheets in construction documentation, and so it's going to be important for us, as we can push our design further and further and have the design become a greater part of the project, we're still going to have to know when to stop. And there's nothing in BIM inherently that's going to do that for you. So let's look at the actual architectural workflow and see where design BIM fits into it. I like to think of architectural design as a 3-stage process. I think of it as the 3 C's: conceptualize, construct, and communicate. Conceptualize, or conceptualization, is the sort of intellectual heavy lifting of the project. It's where you actually figure out what the project is going to be. You're thinking, you're sketching, you're going out to the site, you're taking photographs, you're looking at iconography, you're trying to decide what's the imagery you're going to use or base on this. It's where the project really becomes moves from that idea. It's that good idea that Bruce Goff was talking about, and you move it from the good idea, the core good idea that helps you organize the project, into something that becomes a building. The construct part is, I think, probably more the same for most people. Essentially, we're creating and developing architectural views of the project. You're drawing plans, you're creating a building model, you're extracting views, you might be analyzing and looking at different quantity and cost issues or energy consumption issues. But it's where you've taken that good idea and you've turned it into an actual building. And at some point you have some form of building model at the center of it all. Communicate is where you take that and turn it into drawings, and you enhance the drawings. You add graphics, and you dimension and annotate. You lay out your sheets. You write specs. You prepare that architectural reality that you've created, that you've constructed, and you prepare it for talking to the rest of the world. And particularly, you want to refine the view so that the builder can understand what your intent is and build from it. So the 3 C's: conceptualize, construct, communicate. And it's worth noting how they map onto our traditional phases. They don't have a perfect map, but I think in some ways their 3 makes more sense than the 4 pre-design: schematic design, design development, and CDs that we use today. It's also worth noting that these 3 different modes are inherently different kinds of media. Conceptualization is multimedia. It might be, photography, imagery, site analysis, space planning, any number of variety, and certainly a lot of sketching and thinking going on during the conceptualization process. In the construction phase, BIM is a very good fit. The 2D and 3D architectural objects work extremely well. And as communication is really more 2D graphics and pure data input. Data might be tabular data like schedules, or it might be just database data plugged into your objects, whatever. But the three are all different. The beginning multimedia, 2D, 3D BIM, this well-focused process in construction, and communication becomes more 2D and graphical in nature. BIM occupies the middle, and it's a great fit for the construct phase. And as we've said before, the drawing plans, the building modeling, extracting views, all this is great, and it's a wonderful fit for the center, but it's not the entire workflow. If we look ahead, look at the early parts of the design, one of the things you really want, sketching, sketching is still important. It's a form of thinking. Sometimes think of sketching as this communication between the designer's conscious and his subconscious mind. And BIM needs the ability to capture these sketches, bring it into the construction phase. So what you need is two things. You need integrated tools for specialized front-end thinking, like maybe site analysis, space planning kind of tools. But you also need funneling tools that will allow you to sort of capture media from other, capture into BIM from other media this information. Could be images, could be 3D files of various forms, and tools to transform these abstract shapes into actual BIM objects. At the back end, of course, you need the ability to create readability in your projects. And at the lower left, for example, is an elevational view of a project, perfectly accurate, perfectly correct, and also, frankly, perfectly flat. And you want to be able to enhance those views. As I often tell people, a lot of the BIM people, a lot of the pundits who talk about BIM sometimes say things like, and finally we're going to be rid of drawings. With a model at the center of the process, we're going to be rid of drawings, and they act like that's a good thing. We spent 500 years since the Renaissance refining our graphical communications and the agreed upon methods that we use to communicate. And I wonder why the BIM pundits all think that getting rid of drawings is a good idea. I'm not so sure. I wonder if maybe they got stuck in the back room doing stair details for a little bit too long. But in any case, I like my drawings to read, and I know that this graphical communication is still an integrated and very important part of architecture. So at the back end, I think we still need the ability to take these views that the BIM creates and add, add line weight and begin to do things like texturing and stippling and adding sketch if you want to do preliminary type, add the sketchiness if you wish, and certainly add dimensions and annotations as necessary. There's a lot at the back end that really has to be done on top to get the whole project to read for communication to the client as well as to the contractor. Sometimes the vocabulary provided in those BIM objects can be somewhat banal. So BIM should have the ability to take an arbitrary collection of 3D freeform tools and take the geometry that they create, interact them with the standard BIM geometries, and also attach BIM style information, data, or schedule information to a geometric object. That the Calatrava project there from the 2004 Olympics, the Nations Wall. It's a wall, but it's not a wall you'd find in any BIM program. And I think that we need to remember that sometimes you need that pure geometry that you can then bring into the BIM world. So I've given this talk all over the country, and I'm reminded by my marketing people, since they foot the bill, that this needs to have some marketing content. And I tell them, this is really more of an educational talk. And they say, no, Robert, you gotta go out there and sell. So this is my one marketing slide. I call it Buyer's Guide for BIM. And most of the time I'm talking to medium to small size firms. Let's say 20 people offices and smaller. And when I say they need versatility in the software, they begin to nod their heads and they agree. So what I say is that there are really two major overriding issues. One is that your BIM package should support the entire architectural workflow, the entire 3 C's: conceptualize, construct, and communicate. You want tools to develop that conceptual design, space planning, site modeling, and these funneling tools. You want the object-oriented tools in the middle for construction, and the integrated bill of materials that can read that model-based, that object-based design. And at the back end, you need good graphic arts capability to be able to do the communication part. And so that's one aspect of it. The second aspect of it is look for something that promotes workflow flexibility. In other words, the people in your office have different skills and different experiences, and you should be able to let people just do a drawing. If all they need to be able to do is do a drawing, then let them draw. If they want to model, go ahead and let them model. Give them the ability for the really advanced guys to do abstract, 3D design. Or, as I like to say, just buy Vectorworks Architect. This is my subliminal marketing slide, and I hope you enjoyed it. In the last section of this talk, I want to prognosticate a little bit and talk about what's going to happen over the course of the next 10 to 15 years in the construction industry. In particular, I want to see how BIM and interoperability will change the workflow. I want to start by saying that in the short to medium term, and by this I mean in the 5 to 10 year range, particularly for medium to average size architectural and construction projects, I don't see the role of drawings diminishing. I think that we may see physical paper turn into PDF, we may have electronic viewers, but I think they better be pretty lightweight and pretty portable so that they can be used, and pretty tough so they can be used on the site. So I do, and I think I think getting rid of paper may be a good thing. I mean, I think we may need the trees to turn carbon dioxide back into oxygen, if you know what I mean. But I don't see drawings per se going away, although, as I say, they will become electronic. And I do think architects will continue to control the views of the project that they represent. In other words, we'll continue to have that familiar conceptual delivery of the project in the way we think of now, because really the legal context of the building process isn't going to be keeping up with the technological side of things. So drawings will continue to represent conceptual results. Architects are going to control which are the important pieces of the project they want the owner and the contractor to see, and the inference will have to be to assemble the project from those delivered views. In the midterm, I see communication beginning to share a place with the actual direct sharing of the model. And in fact, if you think about it a little bit, it's happening even today. Every time an owner asks you for a DWG, you're sharing information about the project directly. You're sharing the direct data. And if you think about it, this is happening today for purposes of shop drawings and direct fabrication, some direct fabrication, signage and things of that nature. At the same time, owners are using those space polylines as facility management space data. So we're beginning to see sharing happen a little bit. In the midterm, this is going to become more and more important, more and more commonplace, and we're going to have to think more and more about exactly what are the terms under which this is going to be acceptable. Ultimately, sharing is going to take on the lion's share, if you will, excuse the expression, of the whole role for construction. And I say ultimately because we're really not there yet. There are several issues that have to really be worked out. We have to have a lot more wholehearted interoperability support by software vendors, such as my own company. The BIM software itself will have to become more inferential, such that it can create a more complete model from architectural directions given it by the architect for it to be as complete as is necessary. And And we're going to have to also, and I think this is something that people have tended to gloss over, we're also going to have to create model browsers that can communicate as well as our 500-year post-Renaissance drawing language. One of the contradictions about models is people tend to think that models are easier to understand than drawings are, and I think if they're physical models, they are. But when projected on the screen, models tend to be wireframe, and wireframe models show everything, but can be very difficult to resolve visually. And once you render them to make them easy to resolve visually, then things that are inside them tend to be hidden. So there's this inherent contradiction in showing a model on a screen, and contractors are going to have to learn how to interpret models the way they've learned how to interpret drawings, or some of you may say the way they haven't learned how to interpret drawings because they don't look at them. They're still going to have to look at the models, and there's going to have to be this shared agreement about what constitutes this communication process. But it's going to be happening on a new medium, and so we have things to learn all over again. Interoperability itself is, and the idea of sharing this model, the shared project database, is a really central concept to this new communications in IT for construction. And the likely standard is going to be the IFC file format. It's been an almost 10-year effort by many different vendors and interested parties in the architecture and construction industries, and it's going to win out because it has the most backing right now, and I think it's a good thing. It does. Today you can now on a cross-platform basis, different computer systems, different softwares now uniformly represent a building to a pretty good level of detail. So it allows you to describe a building and share a building into and out of the CAD programs. It does not necessarily mean that you're going to be able to universally edit that building description to the same degree of facility as the originating software. But detailed building description is definitely a start, and the ability to interact with the building description is how we're going to move on from this initial building description of the IFC. But it really is going to help, and it's going to create downstream building analysis, energy analysis, construction bill of materials and costing, and HVAC, and other applications, other specialized purpose-built applications that can read this IFC model that are going to be extremely useful and create a much stronger project team. But, and there's that word again, one of the issues about interoperability is that we really don't have the legal context for construction, for construction communication using model sharing. The A201 general conditions of the contract still are operating under the architect being a conceptual description of the building, and the contractor is the fellow who decides the building process. But with model sharing, you really literally construct the entire building in the computer, and things like construction sequencing are possible, and so we have to find a way to resolve this whole legal context issue that really isn't there yet. It's still going to be a while. The 2007 edition of the A201 isn't going to address interoperability, and I'm hoping they'll put it on a shorter cycle to address further revisions of it, so we can get this new construction process well integrated with the way we do business as architects. So one of the issues that prevent the building information model, this idea of interoperability, from happening, these obstacles are these potholes in the road of good business models. Ideally, we want open and shared communications, but we've still got this idea of risk and reward, particularly for architects, being unbalanced, and we have to find a way to level this out. One of the issues that I think about a lot is digital rights management. Is copyright. How do we protect designs? If you want to see what your life is going to be like in 5 or 10 years, look at the music industry today. And there's Bruce Goff again, comparing the music industry to architecture. But the artists in the music industry today are dealing with copyright and protection issues, and we will be dealing with them as well as our creative endeavors become totally digitized. As I said earlier, the general conditions are going to have to change to support this, and clearly the liability insurance industry is going to have to support interoperability. And I think they look at it as very much a two-edged sword right now. They say, yes, this is something that can reduce errors in the industry and therefore reduce everybody's risk, and it's a good thing. But the architect has to learn how to manage this new setting, and learn how to create expectations in this new setting that's very different from the way architecture is going to be practiced today. Ultimately, it means a change in the architect's practice model. In addition to the business model issues that have to be resolved, we have to have much more meaningful interoperability. We have to have vendors continue their wholehearted support of the interchange file formats, this IFC. Ideally, we'd like to have round-trip editability. And we will see an increasing number of purpose-specific applications for supporting IFC file format, and that's really going to be great. The reasons we want to do this, I mean, we will all gain the ability to become a little more like Frank Gehry, perhaps, and directly fabricate complex designs. But I think the most important short-term is going to be green building and resource management. How do we, performance model our buildings to make them much more efficient in terms of energy consumption, because this is something that's going to have an immediate and short-term payback and drive this whole process of modeling the performance of our buildings better. And for performance modeling, we're really going to have object-based building descriptions. I'll finish this talk up by looking at what I think of as one model for the future of BIM and interoperability. I've always looked at this shared project model in the center of things as kind of a simplistic idea of the project database, of life cycle management for the project, because for one thing, projects don't stay the same. They change, and the needs of the project during construction and commissioning are very different from its needs 5 years into its lifetime, or 30 years into its lifetime, or 45 years into its lifetime. And so this idea of this sort of centralized database is a little too static, and I, as I say, simplistic. So let's look at another possible model. I think perhaps, and there are the three C's, the conceptualization, construct, and now share instead of communicate, a new form of communication, if you will. I'd like to think of the model as a shared project platform that all the various players, here shown in purple, might be able to build on top of, and even create their own separate and specific and individually vouched for deliverables. So, for example, a steel detailer in that second bubble might build upon the shared project model and deliver a set of steel shop drawings in model format that could become his deliverables. Possibly these different players could even be paying for the rights to access the shared project model to the architect, which would be a downstream way of downstream form of revenue that would give him more of a justification for putting the effort in up front. I think this is one possible model, although I think there's many possible models for the way that architects might deliver their data and the way the project team might sort itself out in the future. But I'll leave you with the thought that, I think owners really don't want to wrest management away from architects. I think that they really don't want documents. They really want answers when they call you up and ask you for a question or ask you for a document. I think that it's possible that this idea of a shared project model, or the whole idea of BIM, may be a way for us to, as design professionals, deliver answers to owners. And maybe we can even move into the management as well as the design of our projects. It's going to be up to us. BIM is creating the opportunity. Technology is creating the opportunity. It's going to be up to us to decide what's the best way for us to take advantage of that opportunity. I'd like to thank you all for your time today. If you want to contact me, again, I'm Robert Anderson. This is my email address. We have a BIM white paper on the web. We'll no doubt be supplementing it and adding to it in the interim. This has been BIM in the Real World. a philosophy that we think of at Nemetschek North America, creators of Vectorworks. Thanks again for your time, and I hope you have a great day.